with the peripheral devices, they need to transfer the data or receive the data from the peripheral devices. So here, if we have a microprocessor and a peripheral device, peripheral devices, they can be input-output devices. So when the microprocessor, it communicates with the peripheral devices, it is either going to transfer the data or it is going to receive the data. Now when these peripheral devices, they are located at some remote location, so the microprocessor, it has to transfer or receive the data over the long distances. Okay, now this data, it can be an 8-bit data, or it can be 16-bit data, or it can be 32-bit data or more. So this 8-bit, 16-bit or 32-bit data, it has to transfer over a long distance to the peripheral devices. Also the peripheral devices, if they are sending the data, then also that data has to be transferred. So if such long data, because it's a large amount of data, 8 bits have to be transferred. So these 8 bits, they can be transferred either in parallel transmission or through the serial transmission. Parallel transmission means that all the 8 bits, they are transferred at the same time. Here we are having 8 bits, so all the 8 bits, they will be transmitted at the same time. So this type of transmission is called parallel transmission. Whereas the second type, that is the serial transmission, in serial transmission only single line is used and one after the other the 8 bits are transmitted. Okay, here all the 8 bits are transmitted at the same time. Here in serial transmission only a single line is there and one after the other all the 8 bits will be transmitted. Okay, so there are two types of transmission. Now the microprocessor, when it is transmitting the data over a long distance, it will prefer serial transmission, because parallel transmission, that many number of lines, it has to be connected between the microprocessor and the peripheral device, and there is a long distance between these two. So the serial transmission, it is preferred when the data is to be transmitted over a long distance. Okay, now also in serial transmission, because transmission is taking place over a long distance, so there are chances that errors can occur. Okay, errors means that the transmitted data and the data received by the peripheral device, if they are different, then an error has occurred. So there are chances that error can occur. Also the microprocessor, when it receives the data, it computes all the data in parallel form. Okay, so when it has to transmit the data, it has to convert the parallel data into the serial data. Also when it will receive the data, it will receive it in the form of serial. Okay, serial data form. So it has to convert it into the parallel form so that it can process that data. So every time when it is transmitting the data, it has to perform the parallel to serial conversion, and also when it is receiving the data, it has to perform the serial to parallel conversion. Okay, so conversion also it has to perform. Okay, so in all this, when the microprocessor, it is transmitting the data over a long distances, the problems are occurring. One problem is that it has to do the conversions. Also errors can occur. Also the microprocessor, it is busy in doing all these tasks. Okay, so in place of using the microprocessor, we can use an interfacing device in between this. we can use an interfacing device which will perform all these conversions and all the tasks related to the transmitting and receiving of the data. Okay, this is called an interfacing device because it is acting in between the microprocessor and the peripheral device. It is acting as a communication link between the two. Okay, so for this purpose, Intel has developed a device which is known as Programmable Communication Interface, which acts as an interfacing device between the microprocessor and the peripheral devices which are communicating with each other. That is why the communication word is used. Also interface, because interface is the word given to a device which is act as a communication link between two components. So it is acting as a communication link between microprocessor and peripheral devices. That is why it is called interface. Communication. Programmable, because we can write programs here, we can write the instructions, we can write command word, status word in it, so it can be programmed. That is why it is called Programmable Communication Interface. Okay, and the IC number for this is 8251. So let us study the 8251 Programmable Communication Interface device in detail. E251, which is known as Programmable Communication, that is PCI. So this 8251, it was developed by the Intel for as a communication interface for the microprocessor. It can be used for all the families of the microprocessor like 8080, 8085, 86, 88. So it is compatible with all the microprocessor family. So the first feature of 8251 is that it is compatible with the extended range of Intel microprocessors such as 8080, 85, 86 and 88. Now this 8251, that is Programmable Communication Interface, it is also known as Universal Synchronous Asynchronous Receiver Transmitter. This is called Universal Synchronous Asynchronous Receiver Transmitter because this device, it is acting as a receiver also and as a transmitter also. It is receiving the data also and transmitting the data also. Synchronous, asynchronous, because in the serial transmission there are two types of serial transmission, asynchronous and synchronous. So it can act as both synchronous and asynchronous. That is why it is known as Universal Synchronous Asynchronous Receiver Transmitter. If we take its short form, will be USART. So it is popularly known as USART. Okay, that is the Universal Synchronous Asynchronous Receiver and Transmitter. So the second feature of this 8251 is that it provides both asynchronous and synchronous data transmission. Okay. Now because it is transmitting the data in both the forms, asynchronous and synchronous, so synchronous data bit characters, it can be 5 to 8 bit characters. And also for the asynchronous, it can transmit 5 to 8 bit characters. Okay. Next feature of 8251 is that when we talk about the serial transmission, then it can be half duplex or full duplex. Okay, so this 8251, it is a full duplex double buffer transmitter and receiver. It is acting as both transmitter and receiver, so there will be buffer which is transmitting and receiving the data. It means it is acting in both the directions, so bidirectional buffer will be there. So it is having double buffered transmitter and receiver, which is full duplex. Okay. Now when data is transmitted or received over a long distances, so the 8251, it should keep in mind that errors should not be produced. So one of the feature of 8251 is that it is capable of detecting the errors like parity error, overrun and the framing errors. So all these errors can also be detected, so the data is transmitted and received at a high accuracy by the 8251 communication interface. The 8251 IC, this IC has input and output pins. So all the input and output pins of the 8251, they are TTL compatible. Okay. Also, it is available in 28 pin DIP package. So this IC 8251, it is having 28 pins. Okay. So these are the features of this 8251 programmable communication interface. If we talk about its function, then the 8251, so this 8251, which is known as the programmable communication interface also, and also the universal synchronous asynchronous receiver transmitter, it is universally accepted as the receiver and transmitter by all the programmers. All the programmers, they are going to use this as the communication interface. So what this USART does, it accepts the data. So this USART, it is accepting the data characters from the CPU in the parallel format and converting them into the continuous serial data stream for the transmission. So it is performing the parallel to the serial data conversion when it is transmitting the data. Now when it is receiving the data, then what it is going to do? So simultaneously this USART, it is going to receive the serial data streams and convert them into the parallel data for the CPU. Okay, so at the time of receiving, it is going to perform the serial to parallel conversion. If we describe this functioning in the form of a diagram, here we will have the CPU, or we can say the microprocessor. In between it, we will have the USART. here we will have the peripheral device. So USART, when this CPU it is transmitting the data, it will transmit it in the form of serial. Inside it, it is having the data in the form of parallel. Okay, so this parallel data will be given to the USART. It is going to convert it into the serial data and transmit it to the peripheral device. So it is performing the parallel to serial conversion at the time of transmitting. When it is receiving, it will receive it in the form of serial data, and it is going to transmit the data to the microprocessor in the form of parallel data. Okay, so here it is performing the parallel to serial conversion, and at the time of receiving it is performing the serial to parallel conversion. So in this form, in the form of diagram, we can describe the functioning of the universal synchronous asynchronous receiver and transmitter. So these are some of the features of this USART 8251. Let's summarize these features. It can act as, it is compatible with all the type of microprocessors, 8080, 86, 85, 88, advanced microprocessor also. That is why it is used as an universal, it is accepted as an universal receiver and transmitter. It is available in 28-pin IC 8251. Also, all the input and output pins, they are TTL compatible. It can perform serial transmission, serial to parallel conversion also it can done, and it can also perform the parallel to serial conversion, and both synchronous and asynchronous data transmission can be done by it. So these were the features of the 8251 programmable communication interface, which is also known as USART. So I hope that this topic is clear to you. Thank you.